It's tough to say because we're not dealing with a theory in any sense in which, say, a physicist would recognize the theory. We're dealing with a collection of anecdotes, a certain point of view, a series of hunches. I would say that the most outstanding, the salient points are, first of all, the fossil record, which is simply mystifying. We can't make much sense of the fossil record. It does not sustain any kind of Darwinian prediction that can be intelligently derived from Darwinian theory, and it doesn't seem to sustain anything else as far as I can see. It's a perfectly mystifying record. That's one obvious point. I'm not talking just about the Cambrian explosion. I'm talking about everything that doesn't make a whole lot of sense in the fossil record. Second point, we have never been able in any way theoretically to examine the central Darwinian claim that natural selection and random variation can account for a great deal of complexity. If you look at the history of physics, for example, what did Newton do in the 17th century? He said, well, the planets are being attracted to the sun by a force. It's not any kind of force, it's a inverse square force. And then he went and showed that if you make that assumption, the result will be an orbit that conforms exactly to the observed orbit, say, of the Earth or of Mars. It will be a conic section. And then he proved the converse, that if it's a conic section, the planets must be attracted to a central source by an inverse square law. There is nothing like that in biology, in Darwinian theory. A kind of a canonical demonstration that this mechanism, random variation, natural selection, is adequate to the generation of this level of complexity. From the point of view of the serious sciences, without that kind of a demonstration, one is completely adrift. You have no idea whether the mechanism is adequate for its intended purposes. This is the second point. Third evidential piece of the puzzle. Look, you turn to the serious sciences, you turn to general relativity or quantum mechanics. I can program a computer with the equations of general relativity or with the equations of quantum mechanics, and I can say, all right, what are the consequences? I can actually see the consequences emerge in a simulation. We can't do any of this in biology. And that should prompt any reasonable person to ask, why not? If this is such a simple mechanism, which could easily be programmed on a computer, how come we can't set up a computer and create something of biological-like complexity? How come we cannot see the unfolding of an evolutionary process the way we can see the unfolding of an evolutionary process in physics? This is a very serious question. I've looked at all the genetic algorithms. I'm trying to write a genetic algorithm myself. And the sheer fact is, without a tremendous amount of very special manipulation and ad hoc constraints, the computer is not going to generate anything realistic if it uses Darwinian mechanisms, and it will generate something realistic only if it doesn't use Darwinian mechanisms. This is an important point. 50 years after the computer revolution began, we have a splendid tool for assessing the intelligibility and viability of Darwinian theory. And everything that we know, and I think this is the uniform experience of anyone working in genetic algorithms, indicates these mechanisms will not work. They will not work for their intended purposes. And finally, there's the utter absence of laboratory evidence. I mean, random variation, natural selection, we should be able to start manipulating organisms. When we look at dogs, no matter how far back we go, it's dogs. When we look at bacteria, no matter what we do, they stay bugs. They don't change in their fundamental nature. There seems to be some sort of an inherent species limitation, and we have no good explanation for this in terms of Darwinian theory. We should have far more flexibility, far more plasticity under laboratory conditions than we actually do if Darwinian theory or anything like that were correct. What we see in nature, what we see in the laboratory, is very highly bounded variation, cyclic variation, as for example finch beaks in the Galapagos Island. That's about all we see. Small variations. Why is that if Darwinian theory is correct? These are evidentiary points that I think need to be stressed, need to be examined openly, honestly. And they never are, of course. Never are.